lesson. And this actually, well, so today we'll finish up with lesson 5, which is the review for unit 0 basics, which is the review of science 10. Now, what we have here is a test tube is a numerical response number 1. A test tube that has collected 0.95 grams of ammonium phosphate. Determine the number of moles expressed in the form A dot BC times 10 to the power of negative D. Okay, so this is a question that has a lot of steps involved on it. Now, first of all, the chemical formula for ammonium phosphate is not given there. However, ammonium is in your periodic table is NH4, is a polyatomic ion, and it's +1. And then phosphate is another polyatomic ion, and then you find that, and the phosphate is PO4 3 plus. 3 minus, sorry, 3 minus. 3 minus, not 3 plus. Okay? 3 minus. So the chemical formula for ammonium phosphate will be NH4 3 PO4. Okay, so the very first thing, in order to determine the number of moles in grams, we have to identify what is the molar mass. As we mentioned in the previous lesson, the molar mass will be figured out by finding how many atoms of each we have in the formula. So this is why we need the formula. We have 3 nitrogen in this case, and then we have 12 hydrogen, we have 1 phosphorus, and we have 4 oxygen. Now we go to the periodic table and we see that the atomic mass of nitrogen is 14.1. So 3 times 14.01 plus 12 times 1.01 plus phosphorus is 1 times 30.97 plus 4 times 16 for the oxygen. Now, using your calculator, we will find that the molar mass of ammonium phosphate is, okay, so I have 149.12 grams per mole. What does that mean? The meaning of it is that if you have 1 mole of ammonium phosphate, then you have 149.12 grams of ammonium phosphate. And if you have 149.12 grams of ammonium phosphate, then you have 1 mole of ammonium phosphate. We'll start with what is given. So what is given is 0.95 grams of ammonium phosphate. What is the ratio that we have to use? Is a ratio 1 or ratio 2? On the chart. So will be ratio 1 mole of ammonium phosphate is 149.12 grams of ammonium phosphate. So grams and grams are canceled out. And then what we have is 0.95 divided by 149.12, and the calculator is giving us 0.00637 and so on. Now, the format in which the answer should be recorded is a scientific notation form. So what we will do is we will move the decimal point to the first non-zero digit. So it will be 1, 2, 3. Here is where we will stop. Okay, will be 6.0 0.37 times 10 to the power of negative how many steps we have moved. This is moles of ammonium sulfate. Now you have to look at the answer here. The answer in the calculator is 0, because if this digit here is greater than 5 or greater than 5, then you round up. But since this digit is less than 5, then we keep it as it is. So now, what are we recording in the numerical response are just the numbers 6, 3, 7, and whatever is the digit 3, the digit D, sorry, that in this case is 3. Is this clear? So no space, no comma, no nothing, just the digit 6, 3, 7, 3. So let's move now to the numerical response number 2. So numerical response number 2 is asking the question about aluminum. Okay, aluminum is on, remember now, what did we say? Groups are columns and periods are rows. So in which period is aluminum? Tell me on the period 3, because periods are related to the rows. And now, what is the valence electron of aluminum? 3 as well. Okay, good. Good. Which group is aluminum? Group 13. Excellent. And how many energy levels does the electron have? 3 as well. A lot of 3s on this question. Again, when you are recording this, you will record without space, without comma, or anything like that. Is this clear? Okay. Let's move now to numerical response number 3. How many electrons with selenium have after undergoing ionization? Remember what we said about ionization? That is the process that the atoms are losing or are gaining electrons. On this case, we are talking about selenium. So selenium is, the question will be, is it losing or is it gaining electrons on the chart? It is gaining. How do we know that it is gaining? It's a non-metal, okay? Why? Because it is above the staircase in the periodic table. Okay, it's above the staircase of the periodic table, this staircase here that I'm showing you on the screen. So therefore, the selenium, which has the symbol of selenium is Sa, will gain electron. How many electrons will gain? Will gain 2. Will gain 2 electrons. So now, how many electrons will selenium have under ionization? Selenium, if it is an ion, selenium, atom, the number of protons for selenium will be 34, and since it is an atom, the number of electrons will be the same, 34. But when we have an ion, and on this case, the name of this ion will be selenide. Okay, selenide, which is an ion. The number of protons will be again 34. Why? Because the number of protons doesn't change. The number of protons identify which element on the periodic table you are dealing with. And since it is gaining 2, the number of electrons will be whatever is 34 plus 2, that is 36. So what you will record here is 3 and 6. And Again, no comma, no space, no nothing. Okay, let's move now to numerical response number 4. And on that question, there is a typo as well. Okay, so now what we are doing is we are defining what is the number of atoms on iron 2 nitrate. Okay, as you see here, nitrate not ending with IDE means that is a part of the polyatomic. Now, what we have is that we have an iron that is a multivalent element, has a valence of 2 and a valence of 3. So in this case is a valence of 2. How do we, oh, sorry, a valence of 3. It's a valence of 3. How do we know that it's a valence of 3? It's because they are telling you that it's iron 3 nitrate. Then on the other hand, what we find is that nitrate is NO3 with 1 minus. Okay, so then the formula for iron nitrate will be Fe NO3, the whole thing 3. Okay, now the number of iron on this formula is 1. The number of nitrogen on this formula is 3, because this 3 that is below is the same, has the same kind of effect as the coefficients in math has. They affect everything inside the brackets. And then inside the brackets, we have 3 oxygen times 3 equals to 9. How will you record this into either D2L question, or when you go and write your diploma, is just 1, 3, 9, no space, no comma, no nothing. Clear? Question. Numerical response number 5 deals with balancing chemical reactions. The chemical reaction is given to you, and again, there is a typo there too. You added 2 below the iron in your notebook, please. And now let's balance it. So what type of reaction is this first before we move to balancing it? On the chat, what type of reaction is this? Is a formation, is a decomposition, is a singular replacement, double replacement, or combustion? Balanced chemical reaction will be 2 as a coefficient of iron, 3 as a coefficient of sulfuric acid, 1 as a coefficient of iron 3 sulfate, and 3 as the coefficient of hydrogen gas. Are you here with me? Okay. So the coefficient of 1 we do not, is invisible in chemistry, and on most of the cases in math. When we have a coefficient of 1, we don't write it. However, when we are recording it as a balanced chemical reaction, what we have to state is 2, 3, and then we, even though that in a normal chemical reaction we do not write 1, we still, when we are recording it, will be 1 written there. It's kind of saving the place, and then 3. And again, when you're recording it in D2L, do not have space, no comma, no nothing. Okay, there is any question up to this point? Okay, so on the test on Tuesday, you will see a numerical response, or numerical responses, yes, similar to that, but even a written response, something similar to this. When you will have two compounds that are reacting together, you will state what is the reaction, and then what is important that I don't think that we have been doing here as a review, but you should have done it on Science 10, is when we are identifying the state of matter. So in order to know what is the state of matter. Is it a solid? It is or is an aqueous solution? It dissolves or not? You have to use the table that is on page 6 of your periodic table. So as you see here, the way that you read this table is that the first one is soluble, and so on the first row you have ions. On the second row you have whatever this ion is soluble, meaning that it's forming an aqueous solution. And the third row is not soluble, which means that is solid. So it's not dissolved into the solution. So now let's write we will deal with it when we go to solution unit, which is the third unit in chemistry 20. We'll deal with it. So whomever is writing the state, if it is aqueous or solid or whatever. Is it aqueous and solid will be the one. Or gas. Gas is any gas that is formed, like hydrogen gas, oxygen gas, and all that type. Whomever is writing the state, I will give them bonus marks. So I'm not penalizing you if you do not have the state there, because we will talk about the state of the solutions and the solubility and all that stuff on unit 3 of chemistry 20. So whomever is writing the state correctly, then will have bonus marks. Now go ahead and write the chemical reaction and balance it, and tell me on the chat what is it. This is the chemical reaction, and what is the coefficient near the strontium nitrate is 1. Okay, I see that there. And what is the coefficient near sodium fluoride? Is 2. Now, Camille, what is the coefficient in front of sodium nitrate? And this is 1. Okay, so let's now identify the state of the state. Now what we have is, if you go to your periodic table, you will see NO3 is on the second column of your solubility table. And it says here that is with most of them is soluble beside whatever, RB, ClO4, and so on. That means that the state of matter for this will be aqueous solution. So it is soluble. Okay, and then we move to column 3 where fluorine is, and then it's saying here, but for most of them is soluble, which is on the second row of the table, beside lithium, magnesium, calcium, strontium, beryllium, iron, lead, and another one. So now, sodium is not on that beside, meaning that this is aqueous as well. Now we move to sodium nitrate, and we go again to nitrate, NO3, and then we see that for most of them is soluble. So, and sodium is one of those most. And then for the next one is strontium fluoride. So when we see fluoride here, for most of them is soluble. However, strontium is not soluble, so that means that is solid. This means that a precipitate is formed. What type of reaction is this? We said that is a double replacement reaction. There is a precipitate. Yes, there is a precipitate, and the precipitate is strontium fluoride. You can write the formula, or you can write it in the English name. There is any question on this type of questions? So let's move now to the written response number 2, where we have zinc oxide. So zinc is in the periodic table, as you see, is a single valence element, is +2. Oxygen is -2. So zinc oxide will be, the formula will be ZnO. Okay, great. Determine the molar mass. So to determine the molar mass, we will have to identify the number of atoms on this compound, and that means that we have 1 zinc and 1 oxygen, and using the periodic table, we will go 1 times 65.41 plus 1 times 16, and then using the calculator, we will find that the molar mass of zinc oxide is, so molar mass will be 81.41 grams per mole. Don't forget the units, guys, because as we have said, the units have a meaning. What is the meaning of it? Is that if you have 81.41 grams, then you have 1 mole of zinc oxide, and if you have 1 mole of zinc oxide, then you have 81.41 grams. Okay, so this is the end of lesson 5 and the end of the review from Science 10. What I will do is I will open a practice test for you, which will be counted as the assignment for Science 10 review. So you can have it open books, you can use your notes or the videos or whatever you want, but I strongly recommend you doing that, because the unit test that you will write on Tuesday is very similar to the practice test. Does this make sense? Well,